Hey guys, up today we have 4.6 sum and difference identities. Alright, so to start off, you might want to pause your video and jot down these identities onto your formula sheet. Okay, so anytime that we add or subtract values, okay, we could expand them. All right, and this allows us to actually evaluate. Okay, so these are our sine and cosine equations. There's one for subtraction, one for addition, and these are our tangent. Okay, so you might want to pause and copy down our tangent equations. So a couple different types of problems that we could do with these identities. So the first, we're just going to try and evaluate. So if I have the sine of 15, okay, I need to find, we can use either addition or subtraction, but I need to find two angles that I can either add or subtract to get me 15. Now, the only catch is that we have to use 30, 60, 90 or 45, 45, 90 triangles because those are the only ones that we know the values of. Okay, so any coterminal of those special right triangles can be used. So in translation, what angles do I use? You're going to take out your trig chart, okay, that has all of those values filled in, and you're going to use the top gray rows that have all of the theta values written in them. So you can use any of those theta values when you are doing sum and difference identities. So in order to make a 15, I'm going to do the sine of 45 minus the sine of 30. Now you could make another combination and you'll still get out the same answer. So applying our identity, so difference of sine is sine x cosine y minus sine y cosine x. So this is going to be my x and this is going to be my y. Okay, and I'm going to expand here. So I have sine of 45 cosine 30 minus sine 30 cosine 45. Okay, and again, using our chart, we're going to evaluate each of these. So in the sine row, we're going to find 45 degrees and we're going to get that value. So sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 30 now is 1/2, and cosine of 45 is root 2 over 2. Okay, and now we're just going to simplify. So we need a common denominator, and remember, you cannot add or subtract radicals unless the number inside is the same. Right, so that would be my final answer for that one. Okay, let's try a tangent. So now this is a radian, okay, and my trig chart only has degrees. So I'm going to convert this. Okay, and I get 75 degrees. So now I am trying to make 75 degrees by either doing addition or subtraction of any angles that I have on my trig chart. Okay, so I'm going to choose 45 plus 30. Again, you could probably make another combination and that's perfectly fine. Okay, so This is my x and this is my y. I'm now going to plug them into my identity. So tangent of 45 plus tangent of 30 and now I can use my chart to actually get the values for tangent of 45, tangent of 30. Okay, so tangent of 45 is 1, and tangent of 30 is root 3 over 3. So this is what my problem looks like now. So I'm going to simplify a little bit here. Okay, I'm going to put these over 1 because I'm going to make a common denominator. Okay, and we're going to do order of operations on the bottom here. So we would multiply these first and just get a root 3 over 3. Whoops. I'm going to make this all one fraction. Okay, and now complex fraction, we multiply by the reciprocal of the bottom. Okay, and do some cross canceling. So my final answer, you do not have to rationalize that. You can just leave it. All right, different types of examples is now working in the opposite direction. So here's an expanded identity, and we want to try and condense it. We want to go back. So compare to your formulas. Okay, which one has a subtraction in the middle? Well, that would either be sum for cosine, or that would be difference for sine. Well, which one of those equations takes a sine cosine and a sine cosine? That would be sine, the difference of sine. Okay, so over here, you could change the order of those, because in the formula you wrote down it's sine cosine, which would make your x value 42 and your y value 17, meaning we're doing 42 minus 17. So all I did here is compare the problem that I was given to my identities and see, well, which formula does that one match? And then you just want to fully simplify here inside the parentheses if possible. So we're looking for sine 25. Okay, doing the same thing on the second example. Sine cosine again, and now there's a plus. This is sum of sine. If you compare it to the sum of sine identity, this equation matches, making your x pi over 5, making your y pi over 2. So we're going to condense, we're going to go backwards. Okay, and I can actually add those together. We get sine of 7 pi over 10. Okay, we could also prove, we can do proving way back to 4.3, 4.4. We could prove using these identities now. Okay, so the left side here, I have a difference of cosine. So that means that x equals 180 and that my y is just theta. Okay, so I'm going to expand the left side here. into cosine of 180 cosine of theta plus sine of 180 sine of theta. And we're trying to prove that it equals negative cosine of theta. Well, I can actually evaluate anything that has an angle in it. Cosine of 180 is -1, and sine of 180 is 0. Okay, so -1 times cosine is negative cosine, and 0 times sine, that's going to cancel out. So all we're left with is negative cosine, which proves this identity. Okay, so sum and difference are very, very simple. There's not a whole lot that we can do with these identities.